Alright, we have some double angles we're doing here. It says, given that the cosine of theta is root 5 divided by 5, and that theta is in the first quadrant, find the cosine of 2 theta. Now the nice thing here is we don't need to draw the triangle yet. We will when we get here. But cosine of 2 theta, we have, as we went over in class, these 3 formulas. Now for the most part, we're not going to really use that one because it involves the cosine and the sine. We could if this had been tangent, because then we'd have to draw the triangle and we could do cosine and sine. But the nice thing is here, it gives us one formula where it uses cosine and one formula where it uses the sine. So since we've already been given the cosine, it only makes sense to go ahead and use that formula to figure out the cosine of 2 theta. Now, the formula says to do 2 times the cosine of theta squared. So the cosine is root 5 over 5, and we're going to square that. And then we have to subtract 1. When we square this, well, remember, root 5 over 5 times itself. Well, root 5 times root 5 is 5. 5 times 5 is 25. That just simplifies to what? 1/5. So this is 2 times 1/5. 2 times 1/5 will be 2/5, and subtract 1 whole unit. If we're subtracting a whole unit, that's the same as saying, okay, you're subtracting 5/5 from the 2/5. And it'll give you your answer of -3/5. There's our answer to the cosine of 2 theta. Now when we come to the sine of 2 theta here, where we're trying to do a double angle with the sine, we have to use this formula, which means we got to find the sine and the cosine. Well, I already know the cosine, but I don't know the sine, so I'm going to have to draw this triangle. Draw it right here underneath. Okay, and here's theta. It's a right angle. This is in the first quadrant, opening up into the first quadrant. So we know the cosine is root 5 divided by 5. Well, cosine is what? Adjacent. So this side is root 5 over the hypotenuse, which will be 5. Now we just need to find this side here. Well, we will, as normal, use the Pythagorean theorem. So it's going to be this side squared, so root 5 squared plus the unknown side squared will equal the hypotenuse squared. We get 5 plus b squared is 25. We subtract 5, it's going to give us b squared is 20. Take the square root. Well, we would get plus or minus, but since we're talking a length, it's only the positive that we want. If we simplify that, remember this is a 2 times 2 times 5, so a 2 could come out, so it's going to be 2 root 5. So that's what we have there, 2 root 5. So if we go back to the formula says do 2, I'm going to just put it over 1, times the sine value. Well, what is the sine value? Well, it's just, we got b was 2 root 5 right here. Okay. The sine value is opposite, 2 root 5 over 5. It's 2 root 5 over 5 times the cosine value. What's the cosine? That's the adjacent, root 5 over 5. Now we just need to see what all this gives us. Well, up top you have 2 times 2, which is 4. Root 5 and root 5 is how much? Well, that's just a 5. So 2 times 2 is 4, times that 5 gives me 20 on top. 1 times 5 is 25. That gives us, simplifies to an answer of 4/5. A little bit messy in here, but that's okay. You should be able to see what I did. So, there's the answers to problem 1 for you.